Imagine spending months crafting a cutting-edge AI model that works brilliantly in the lab only to watch it falter in the real world. Data pipelines break, model performance degrades, and the project stalls. Unfortunately, this scenario is more common than you might think. Research reveals that roughly 80% of AI projects never even reach production deployment. In financial services, for example, 80% of AI projects fail to make it to production at all. And of those that do, 70% fail to deliver meaningful business value, often due to poor data quality rather than technical glitches. These sobering statistics beg the question, what's going wrong? And how can we bridge the gap between promising AI prototypes and reliable, valuable AI in production? The answer lies in operationalizing AI through two emerging disciplines: MLOps and DataOps. MLOps, short for machine learning operations, and DataOps, short for data operations, have become the essential pillars for taking AI from the lab to the field. They tackle the often overlooked challenges that arise after you build an AI model, challenges in deployment, monitoring, data management, and maintenance. In a nutshell, MLOps focuses on the machine learning model lifecycle, from development to deployment and upkeep, while DataOps focuses on the data lifecycle, from ingestion to preparation and delivery. By adopting MLOps and DataOps, organizations can transform ad hoc AI experiments into robust, scalable AI products. It's no surprise that industry trends show these practices are on the rise. Gartner has predicted that by 2025, 70% of enterprises will have operationalized AI by using MLOps practices, and surveys indicate about half of organizations plan to boost their DataOps investments to improve data access and quality for AI initiatives. In other words, to truly leverage AI at scale, MLOps and DataOps are no longer optional. They're mission critical. So, what exactly are MLOps and DataOps? Let's start with MLOps. MLOps is a set of practices and tools that apply the proven principles of modern software DevOps to the world of machine learning. Think of it as building an assembly line for your AI models. Instead of the traditional painstaking process where data scientists manually train a model, hand it off to engineers, who then struggle to integrate it into an application, MLOps provides an automated, streamlined pipeline. According to IBM, MLOps helps companies automate and accelerate the deployment of ML models, ensuring that everyone involved, data scientists, engineers, IT operations, can collaborate smoothly to monitor and improve model performance. This means introducing practices like version control for datasets and models, continuous integration and deployment, CI/CD for machine learning, and automated testing and monitoring of models in production. The goal is to quickly and reliably move ML models from development into production environments and keep them running smoothly thereafter. Without MLOps, a brilliant model might remain a one-off experiment. With MLOps, that model becomes a repeatable, maintainable service that delivers value continuously. Concretely, MLOps covers the entire ML lifecycle. It starts from data preparation and training, continues through model validation, and crucially extends to deployment, ongoing monitoring, and maintenance of models over time. For example, a team practicing MLOps will have automated pipelines that retrain and redeploy a model when new data is available or when performance drifts. They'll use tools to track different versions of models and the data they were trained on, ensuring results are reproducible and auditable. They'll set up alerts to detect when a model's predictions start to diverge from expected patterns, a phenomenon known as model drift, and trigger retraining if necessary. In short, MLOps adds rigor and automation to what used to be an ad hoc process. The payoff is huge: faster iteration, fewer failures in production, and greater confidence in the AI's outputs. As evidence of its importance, experts note that by now, MLOps has become foundational infrastructure for AI-driven companies. especially in critical sectors like finance and healthcare, where reliability and compliance are paramount. When done right, MLOps turns machine learning from a one-time project into a sustainable, scalable asset for the organization. However, even the best model operations will falter if the data feeding the model is unreliable. This is where DataOps comes into play as the indispensable counterpart to MLOps. DataOps applies the same philosophy of automation, collaboration, and continuous improvement, but to the data pipeline rather than the model pipeline. In essence, DataOps is a set of collaborative data management practices designed to speed up data delivery, maintain data quality, align data work across teams, and extract maximum value from data. Modeled after DevOps, DataOps seeks to break down the silos between data engineers, analysts, and other stakeholders, making data pipelines more agile, automated, and reliable. Picture all the steps that raw data goes through in a modern enterprise, from being collected in databases or streaming platforms, to being transformed and cleaned, to being loaded into analytics dashboards or machine learning models. DataOps aims to orchestrate this entire journey seamlessly. It introduces automation for moving and transforming data, monitors data flows for errors or delays, and implements checks to ensure data quality, so that, for instance, a sudden spike in missing values or a schema change doesn't break everything. By replacing manual, error-prone data handling with automated and tested workflows, DataOps ensures that high-quality data continuously flows to all the systems that need it, whether it's a business intelligence report or an AI model. Why is DataOps so critical? Because even the most sophisticated ML model will fail if fed bad or inconsistent data. As one expert bluntly put it, without clean and reliable data, even the most sophisticated machine learning models are destined to fail. Many AI project failures can be traced not to the algorithms, but to data issues. Out-of-date data, data that's inconsistent between training and production, or data pipelines that can't keep up with real-time needs. DataOps tackles these problems head-on. It emphasizes data quality and governance as first-class priorities, embedding data validation and testing throughout the pipeline. It also fosters communication. Data engineers, data scientists, and business users collaborate under DataOps to ensure that the data collected and prepared truly meets the needs of its end use. For example, DataOps practices would insist on metadata management and data lineage tracking, so you always know where a given data point came from and how it's been processed, and might implement automated alerts if a data feed stops or deviates from expected ranges. The impact of DataOps is faster, more reliable insight delivery. Reports aren't broken due to missing data, and models always have fresh, trustworthy data to learn from. In fact, organizations are learning the value of this approach. DataOps is becoming a strategic investment area, with nearly 50% of companies surveyed planning to increase DataOps spending to improve data access and quality. By accelerating data delivery while maintaining high quality and governance, DataOps provides the solid foundation on which successful AI solutions are built. You can think of the relationship between these two disciplines, MLOps and DataOps, like a building's foundation and its structure. DataOps is the foundation, making sure the ground, i.e. data, is solid. And MLOps is the structure built on top, the AI model and its deployment. They are complementary and work best when implemented together as a unified ecosystem. If you only focus on MLOps, the model side, but ignore DataOps, you risk deploying a great model that later crumbles because the data feeding it is flawed or stops flowing. Conversely, if you only focus on DataOps, the data pipelines, without MLOps, you might have excellent data available, but struggle to ever get stable, scalable machine learning models into production to make use of that data. For AI to deliver real business value consistently, you need both. DataOps ensures the right data is available, and MLOps ensures the right decisions are derived from that data via models. When both practices are in place, they reinforce each other. DataOps provides clean, timely data for model training and inference, while MLOps provides feedback to the data team on what data is most useful or when data distribution shifts, which might require collecting new data or adjusting pipelines. It truly creates a virtuous cycle of continuous improvement. Better data leads to better models, and better models highlight needs for even better data. To make this abstract concept more concrete, consider a real-world example. Imagine a bank that deploys an AI-driven fraud detection system. The DataOps team ensures that streams of transaction data from various sources, credit card swipes, online banking, etc., are being collected in real time, cleaned and formatted consistently, and made readily available for analysis. They've automated the data pipeline so that as soon as a transaction happens, it flows through quality checks and into the fraud detection system's database within seconds. They monitor this pipeline for any delays or glitches, say, if one data source goes down or starts sending anomalous values, the DataOps team is alerted immediately to fix it. Meanwhile, the MLOps team takes the machine learning model that flags fraudulent transactions and deploys it into a scalable production environment, perhaps a cloud service, so it can handle thousands of events per second. The MLOps framework tracks the model's performance. If the model's false positive rate or false negative rate starts creeping up, maybe as scammers devise new tactics, the monitoring dashboards catch it. The team can then retrain the model with up-to-date data, which, thanks to DataOps, they have in abundance and high quality, and roll out the improved model seamlessly through a CI/CD pipeline. In this scenario, DataOps ensures the data feeding the fraud model is timely and trustworthy, while MLOps ensures the fraud detection model itself is well managed and continues to perform optimally. The result for the bank is a fraud detection system that is both reliable and adaptive. It's catching fraud based on the latest data and quickly updating itself as fraud patterns evolve. Without DataOps, the model might be starved of fresh or accurate data and miss new fraud trends. Without MLOps, the model might be stuck in an outdated state or even crash in production without anyone noticing. Together, they keep the system running like a well-oiled machine, from raw data to actionable insight. Implementing MLOps and DataOps is as much about culture and process as it is about technology. On the technology side, there's a growing ecosystem of tools. For instance, tools like Apache Airflow or dbt for orchestrating DataOps pipelines, and tools like MLflow, Kubeflow, or Amazon SageMaker for managing MLOps workflows. Automation is a common theme. Teams should automate everything from data validations to model testing and deployment. But tools alone don't solve everything. Successful operationalization of AI also requires a mindset shift and coordination across roles. Data scientists, data engineers, ML engineers, software developers, and business analysts all need to work together, often in cross-functional teams, rather than throwing work over the wall to each other. Breaking down silos is key. The collaboration fostered by DataOps and MLOps means, for example, that data engineers understand the needs of the models, and data scientists are aware of data pipeline realities. This collaboration is supported by practices like shared version control, so code and data changes are transparent, peer reviews of pipelines and models, and jointly defined metrics of success. Moreover, governance and monitoring have to be baked in. Both DataOps and MLOps advocate strong governance. Data governance in DataOps for privacy, security, compliance, and model governance in MLOps for accountability, fairness, regulatory compliance in AI. Teams should establish clear policies, for example, how to handle data access and lineage, or how to approve a model for deployment, perhaps requiring ethical checks or performance benchmarks. When an organization gets these elements right, the payoff is dramatic. They can deliver new AI features faster, since everything is automated and repeatable, with higher quality, since data errors or model drifts are caught and fixed early, and with greater trust from stakeholders and customers. In short, the organization becomes truly data-driven and AI-powered, not just in prototype, but in day-to-day operations. As we look to the future, operationalizing AI through MLOps and DataOps is only going to become more important. AI models are growing more complex and pervasive, and regulatory scrutiny around data and AI is increasing. Companies that have a chaotic, manual approach to managing data and models will struggle to keep up. On the other hand, those that invest in robust DataOps, MLOps pipelines stand to gain a competitive edge. They'll be able to adapt quickly when conditions or data sources change, and they'll be able to scale their AI initiatives with confidence. Industry experts predict that the line between DataOps and MLOps will continue to blur in the coming years, as successful teams integrate both into an end-to-end AI operations strategy. New trends like real-time analytics, streaming data, and online learning models will demand even tighter integration of data and model operations. We might also see emerging best practices around things like managing synthetic data or handling continuous retraining of models, further uniting the data and model workflows. But at the core, the principle will remain. Operational excellence is the secret sauce that turns AI from a one-off experiment into a lasting business asset. In conclusion, operationalizing AI is about making AI actually work for an organization day in and day out. And that requires both MLOps and DataOps working in harmony. By establishing a solid data foundation, DataOps, and a reliable model deployment process, MLOps, companies can finally bridge the gap between AI hype and AI reality. Instead of a flashy demo that never goes anywhere, you get AI systems that are resilient, scalable, and continuously improving. The stakes are high. Recall that without these practices, the majority of AI initiatives flounder or fail to deliver value. But with MLOps and DataOps, those odds can be flipped in your favor. The organizations that master this dual competency are positioning themselves to lead in the AI-driven economy, where insight and intelligence are delivered not as one-off projects, but as reliable, on-demand services. Operationalizing AI through MLOps and DataOps is how you turn promising ideas into addictive, real-world results, ensuring your AI innovations truly make a lasting impact.